Welcome to qnawire.
Hi everybody. So this is the diagram given in the textbook. So here all the measurements are given in feet and LB, and in point in point H you can find a support there. You can see that that is a roller support. So due to this support, because of this support, there will be one reaction, that is vertical reaction. So let's name this vertical reaction as HY, as it is in point H. Let's name it as HY. Now in point A, you can see another support there, and the name of that support is pinned support. The specialty of pinned support is because of this support, there will be two reactions. There will be one vertical as well as one horizontal. So there will be a vertical. Let's name the vertical reaction as AY, and there will be one horizontal also. Let's name this horizontal reaction as AX, as these two are in point A. Let's name according to that. So now let's mention the reaction here in the diagram itself. This is HY. Here this is AY, and this will be AH. So, and let's name this angle here, this as beta, and the angle here, that as theta. Now we have drawn the free body diagram. So to use the method of joints, first let's start with the analysis of this free body diagram of the center truss, and then we look for joints connecting maximum two members with unknown internal forces to solve with force equilibrium equations. Now let's find the angle theta and beta. So theta will be tan inverse opposite by adjacent. That is, the opposite will be 72. Adjacent will be 10.54 plus 12.5, that is 23.04. The angle is 16.26 degree. Now about beta. Beta will be tan inverse opposite is 6.72, and the adjacent is 10.54. So here the angle we got it as 32.52 degree. Now let's resolve along equation of equilibrium. Summation of moment at A equal to 0 gives us minus 5.76 feet into 800 lb. First force 800 lb, so we are not going to write the force. Yeah, minus the next distance 11.52 into 800 lb, the next 800 minus to the next force, that distance will be 17.82, sorry, 17.28. So 17.28 feet into again 800 minus 23.04 feet into 400 plus 23.04 hy equal to 0. So from here, the only unknown here is hy. So we can write the value of hy directly. So we will get hy equal to 1600 lb. Now let's move to each joint and find for each joints. So firstly, let's consider joint H. So for joint H, the diagram will look like this. If this is joint H, there will be a 400 lb vertically upward, so from upward to downward 400 lb, and there will be hy just opposite to that. This is hy, and the fgh and fh. Now this angle here, that is theta. We name that angle as theta. So now let's calculate the summation along y equal to 0 gives you hy minus 400 minus fh sin theta equal to 0. So here we just found the value of hy. Substitute the value of hy in this equation and we can find the value of fh. So therefore the fh will be equal to 4285.77 lb, and the ffh is actually going inward to the point H. You can see that remark here. So that creates compression. Let's denote it by the letter C. Now summation along H equal to 0 gives you minus ffh cos theta minus fgh equal to 0. So we just found the value of ffh. Substitute the value of ffh in this equation and we will get the value for fgh. Therefore the fgh will be equal to 4114.34 lb. The fgh is actually going upward from the point H, so that creates tension. That's denoted by the letter T. Now let's move to the next joint. Let's take joint F. So for joint F, let's draw the diagram first. If this is joint F, there will be a 800 and there will be fh and the FDF, this is FFH, this is FDF, and FFG. So here this angle is theta. Yeah. Now let's solve for the joint F. Summation along X equal to 0 gives you FDF minus FFH plus 800 into sin theta equal to 0. So from here we just found the value of FH here, substitute the value of FFH in this equation, and we know the value of theta, so we will get FDH directly, that is the FDF will be equal to 4061.77 lb, and the FDF is actually going inward to the point F, that creates compression. Let's denote it by the letter C. Now summation along y equal to 0 gives you FFG minus 800 lb into cos theta equal to 0. So here the only unknown is FFG, that is therefore FFG will be equal to 768 lb, and here the FFG is actually going inward to the point F, that creates compression, so let's denote it by the letter C. Now let's move to the next joint, that is joint G. Let's take a look. Joint G. For joint G, let's draw the diagram first. If this is the G, there will be FGH here and FGE and AFG and FDH, FDG. So this angle here, that we named it as theta, and this angle is beta. We found the value of theta and beta. Now let's go and resolve this. So the summation along y equal to 0 gives you minus FDG sin beta minus FFG cos theta equal to 0. So here we just found the value of FFG, substitute the value of FFG in this equation, then we will get, therefore FDG will be equal to 1371.86 lb, and this FDG is actually going outward from the point G, that creates tension, so let's denote it by the letter T. And summation along H equal to 0 gives you minus FDG cos theta minus FGE minus FFG sine theta. Oh, oops. Sorry, this is beta. Yeah, the angle in FDG, this is beta. So this is cos beta. So plus FGH will be equal to 0. So in this equation, the only unknown is FGE. All the other values are, we already got the other values. So just substitute the value for FDG, FFG and FGH. Then we will get the value of FGS. FG will be equal to 2742.55 lb. So FG is actually going outward from the point G. That creates tension. That's denoted by the letter T. Now, I hope you understood the problem. Thank you.